A very good morning and welcome everyone. Thank you for joining us at e-KLESF 2022. I'm Dr. Ong Kia Ju from University Tunku Abdul Rahman, Utah. Today we are presenting a webinar titled When Metal Returns to its Original Condition, Can We Stop It? By T.S. Ng Chanwa. T.S. Ng is a senior lecturer at Tunku Abdul Rahman University of Management and Technology, TAR UMT. Just a little housekeeping before we start. If you have any questions, please type them in the chat box. We will bring them up during the Q&A session at the end of this webinar. Dear participants, please sign in your attendance in the link posted in the chat box. Without further delay, let us turn the time over to T.S. Ng.
Okay, good morning, ladies and gentlemen. From wherever you are, okay, let me share my screen. Oh. Okay. So can you? I'm sure you can see my screen. Can you see my screen? Yeah. All right. So, wait, yeah, I'm having some technical problem here. Wait. So I think I should share from here. Okay. Good morning once again, ladies and gentlemen. Okay, I'm sure you can see my screen now. So the topic I'm going to present today is when metals return to its original condition, can we stop it? All right. First and foremost, I'm sure some of you might be able to know what are the topic or what will be the topic that I'm going to discuss, share today. So by the way, can you see my screen? Hello, can you see my PowerPoint presentation?
Yes.
Yes, huh? Yes. All right, very good. So I'm sure, let's say looking at this so-called screen here, I'm sure you'll be able to know, oh, let's say I'm talking about a boat here, a boat. So for example, before, all right, before, that is where we get, all right, but then after a certain period of time, then you're going to find out that, our frame will start, to so-called to corrode. Okay, and this is something that we used to see, and this is the topic of my presentation today. And when the metal return to their original condition, so meaning to say the metal, most of them are found in their original condition, whereby they apply or appears in something like that. But the question is that what can we do? If let's say we were to stop it. So talking about this, then basically some of you might be having the impression that, oh, I'll be talking about something to do with chemistry. The answer is yes and no. Okay, why? Because the process involved in changing the structure from before into after, of course, involve certain chemical reaction or but then the question for today is that we are not going to touch so much into chemistry. Okay, so that is basically the original condition that we are talking about. Now, at the end of this session, so you're expected to see what we call, I'm sure you should know by now that we are talking about corrosion. Okay, and then we will touch something on types of corrosion, and then know what thing we can do to prevent the metal from going back to its original condition. So that's basically what we're going to look into from the whole section over here. All right, now let's go into a little bit history of metal extraction. Now, when we talk about metal extraction over here, I'm sure you know, or some of you know, originally metal, they don't occur, in the original condition, whereby they are all available, in the so-called ore condition. All right, so now since metal are available in this so-called ore condition, then they are basically, what we consider to be not suitable. Not suitable to be used, for engineering application, for domestic application. So that's why, because of that reason, then we have to do something, all right, to extract, extract the metal from its impurity, or separate the metal, from the rocks, for example, from impurity, then whereby we will be able to extract metal at the end of the day. So in the process of doing that, originally, we're going to find out that these ore are available in a very stable condition. But the moment you are going to separate them from their frame and so on, then they will become unstable. So once they become unstable, then this is going to be a problem. Okay, once they become unstable, then they will find their way to go back to its original condition. So that's why you can see from this picture here, this is a piece of iron ore, for example, which is actually used to making steel, all right, to make metal. Okay, for example. Now, in the process of converting them into something usable, you're going to find out that, they will become so-called stable. This is a stable condition, but this stable condition is not able to use. So that's why, because of that reason, we have to change them into something which is called metal, which is something that we see. So, but unfortunately, this process is turning the metal or the ore become an unstable so-called structure. So given time, they will find their way to go back to their original condition. All right. So this is a thing that we can see. Now let's talk about how to convert the metal from what we call from an unstable condition, all right, into what we what we consider to be metal here. So that's why we have to use a furnace, a big furnace. All right, in the process of making the furnace here, it's gonna be we're gonna put all the raw material as well as some fuel, as well as some so-called slag remover, and then dump everything into the furnace here. Then in the process of the reaction, of course they are having some chemical reaction in between along the way, whereby we will find out that the coke, all right, not Coca-Cola, but then the fuel will start to react with the gas, and then they turn into carbon monoxide, and so on. And most importantly, you can see at the end of the day, we will be able to convert the metal originally, whereby they are found to be in an iron oxide condition, and then turn them into something usable. So of course we have iron, iron in liquid condition. So that is the first step involved in the reduction of iron ore. And this is the first step by which we are going to turn something into something not usable into something usable. So that's why in the process of doing that, then you will have to put in some energy, in fact, a lot of energy, to make them able to convert into something that you see. So that's why you can see the temperature, all right, can be as high as 1005 degrees C or even higher than that. All right, so now the whole so-called extraction process is used, involve the use of what we call fume, as well as some hot air. So the hot air, of course, will somehow result in certain chemical reaction, which is not going to be subject for the topic for today. But at the end of the day, ultimately, you will be able to see metal. We will get metal. So that's why we will obtain the molten metal at the bottom of the furnace. Then we will use them to make metal, to make something that we see. Now, of course, you can see from the slide, like I told you that just now, whereby involve a lot of chemical reaction, whereby you use limestone. All right, limestone is something that we use to remove the impurity. All right, so that's why at the end of the day, you'll be able to get waste solid, so which is in the forms of slag, so-called slag. And then we will get the metal, the molten metal at the bottom of the furnace, which is called pig iron. Then from there, we will do something to make them into something usable, for example. Now, the process of extracting metal consists of three basic phases. Of course, they are enrichment or concentration of the ore, whereby you have to put the ore inside, dump them inside the furnace, and then you start to go through or let them go through certain chemical reaction. And after the chemical reaction, then you will be able to get what you want, which is called the iron. The iron in forms of what we call pig iron. And then at the end of the day, we will do, say, some addition of alloy. Some alloy or addition, or maybe no additional, added some alloy or even carbon to make the metal, to refine the metal into the structure that we want. For example, you can make carbon steel, you can make stainless steel, you can make, for example, different types of alloy steel. But in the process, like I said just now, unfortunately, you are going to turn the stable iron ore into something unstable condition. So that's why nothing is going to last forever under the sun, even though a piece of metal we are using. So in the process by which they will turn themselves from a stable condition or from unstable condition into a stable condition, whereby they will turn back to this original condition, which is in the ore condition. This process involves something called corrosion. All right, so before I go into that, let's take a look into the chemical reaction again. Then we are going to make them originally. This is going to be iron oxide, whereby this is in unstable condition or a stable condition, then you put in energy. So by putting energy inside, all right, then you're going to get through a so-called reduction process, you will get Fe. So this is a process being used, okay, for hundreds of years in the process of extracting matter from its original condition. All right, so this is what we see. Now, of course, you will be able to find out that then the basic chemical reaction is going to be metal oxide or iron oxide turn into, okay, usable iron, and then to produce some, okay, some carbon monoxide and so on. All right. Now, this reaction causes damage and in this integration of the matter, starting from the portion of the matter exposed to the environment, and then spread, okay, and spreading into the entire bulk of, okay, of the what we call the metal. Now, when we talk about, okay, when matter return to its original condition, okay, like I said just now, something that you get over here, unfortunately, they are not stable. Okay, they are not stable. So that's why they will somehow turn, okay, to return to its original condition. So that's why, let's say this is a method that we are using, okay, I mean, in our daily life, let's say this is a matter chain, for example. Now, given time, this matter chain will somehow return to its original condition. Why they tends to return to their original condition? Because they are stable. Right, they are more stable in their original condition than their unstable condition. So this process, what is the name of this process again? So the name of this process is called corrosion process. So that's why you can see the corrosion process usually, most of the corrosion process usually will start from the surface, okay, of the matter, and whereby they are start to react with what? React with the environment. Now, when they start to react with the environment, for example, water, okay, for example, oxygen, then you're going to find out that, our friend will start to corrode, okay, and they will form what we call oxide film. So this oxide film, if let's say you look at this structure here, they are porous, okay, and or at the same time, they are very active. Okay, active meaning to say the corrosion process will keep on going until the whole piece of metal turn into oxide. So turn into oxide, so meaning to say they will turn into something. All right, why they want to turn into something? Because they want to return to their original condition. So this is a process of corrosion, and this is a process we are going to discuss today. And then what we can do if you want to stop the process. Okay, I want to stop them from returning from the original condition, or I want to at least delay them from going back to their original condition. So what we can do, or what can we do? Okay, for example, now why we want to stop them from going back to their original condition? The question is that when they return to their original condition, then you're going to find out that, this iron will have originally, when they are in an unstable condition, then they will, what we call well known, all right, to have good tensile strength, have a good rigidity. But when they start to return to their original condition, for example, well, the iron will tend to become brittle, will become brittle, will become flaky and become so-called structurally unsound. So unsound means not good to use and not safe to use. So what happened? Have you ever seen some structure in your surrounding or some metal turn into something like that? Have you seen before? Then this is corrosion. All right, this is oxidation, this is corrosion. So looking into this structure, then you can see that there are some cracks formed, and the structure, the so-called the oxide film, all right, they are become so-called flaky. And then most importantly, this is an active process, meaning to say the whole metal will return, all right, to their original condition. The whole piece of metal, like we have seen just now, all right, originally this is a metal we are talking about, but then once oxygen, once water come to contact or attack, then the whole piece of metal, first and foremost, they will form metal oxide, or iron oxide at the surface. But as the time goes by, then they will somehow, so-called attack the whole piece of metal, and eventually they will come back to this original condition whereby they are not able to use anymore. So this is the reason why we want to prevent them. because I don't want my metal to become non-brittle. I don't want them to become structurally unsound. So what we can do, okay, we must understand how the process, and we have to recognize what is the consequences, and so, okay, and something like that before we can do something about it. All right. So this is basically the whole idea. All right. Now, when we talk about matter returning to its original condition, now, first and foremost, we have to make sure, we have to understand why or how come they will return to their original condition. Now, when the process return to the original condition in the layman term, this process is called rust or rusting. All right. So it's a rusting process. Rusting process is a process where the iron metal corrode in the presence of oxygen, all right, as well as water, then resulting in a reddish brown surface. All right, so we have seen this now, then the surface become red in color, okay, reddish brown, brownish color and something like that. Now, they will occur, or it occur when metal or iron oxidizes again, all right, in the presence of water, all right, as well as oxygen. So this is basically, you know, something that, you know, we've been saying, you know, over and over again. This is a corrosion process, or this is a rusting process. All right, I'm sure, okay, we have seen it, okay, before. Now, let's talk about some, what we call, you know, some process, okay, or some electrochemical reaction. All right, even though today we are not here to share chemical reaction, no, I'm not here to share, but somehow in order for us to understand the corrosion process, for example, okay, where's my mouse? Okay, corrosion process, for example, let's say rusting or even corrosion of iron. Now, first and foremost, we have to understand, you know, two very important things. Okay, of course, we want to get, okay, we will get rust. Okay, that is something we do not want to see. This is going to be the iron. All right. So unfortunately, we can't prevent them. Okay. Once, like I said just now, we have water and oxygen, then what we should do, okay, or what we will say, this oxygen and water, they will attack. All right, they will attack my metal. Then ultimately what happened? Then this is something we will form rust. So now, in order to understand or prevent this process, then we have to understand what we call how this rust, okay, will form on the surface. So in order to do that, then we have to understand, we need two things, all right, to complete the process. First and foremost, we need to have anode, we have to have cathode. So now, anode is a place where you can see, the metals start to dissolve. All right, the metals start to dissolve, and then in the process of this, okay, so-called dissolution, then somehow electron will form, and then electron will travel to cathode, and whereby the electron in that cathode somehow will combine, all right, with oxygen, for example, and that is where they will generate water. All right, so these are the two things which we have to, okay, understand: anodic side as well as cathodic side. Then ultimately you can see the water that we produce, wow, they will somehow combine with the product that we get, meaning to say the oxygen as well as the iron. Oxygen with the iron, metal iron or ferrous iron, they will combine, and then the water ultimately will combine with the product that you get. That's why you can see we will get metal oxide, then saturated, okay, with what we call water. Okay, so this is a thing that we see. Now, just to break down the chemical reaction, okay, a simple chemical reaction into two chemical reactions, whereby involve the use of anodic reaction as well as cathodic reaction. Okay, of course you can see this is gonna be part of the equation. That's why you can see half reaction, and this reaction is actually classified as oxidation. Now, what is oxidation? Oxidation process is a process whereby the metal will be oxidized, okay, or will be ionized, whereby, okay, they will form Fe2 positive. All right, and also with the formation of two electrons. All right, so now the electron travel to where? The electron will be then travel from anode, then to cathode. So then they will find out that the electron will combine with the so-called hydrogen ion from the water, and then they will combine and then to form what we call water. Okay, they will form water. So this is basically the process involved, okay, in corrosion process or rusting process in the layman term. All right. So what are they? So which is actually classified as anodic reaction as well as catalytic reaction. So the metal ion, all right, form at cathode, all right, and then react with oxygen from the atmosphere, like I said just now. Oh, these two things will combine. Once they two things combine, they will become very happy. Why? This is a time when they become, well, stable. Okay, they will become stable. So forming iron oxide, and then which come up in the hydrated forms. So hydrated form, what is the meaning of hydrated form? So hydrated form is that they will combine with water. All right, with water. So I don't care how much water I have, so long as I know, oh, this metal oxide, okay, or the iron oxide will combine. All right, will combine with water. So of course, at first you will see this will be the reaction that you see. All right, metal ion, and then subsequently they will somehow combine with water, okay, to form the product. Okay, this product which is classified as rush. Okay, at the end of the day, and this process is corrosion process. All right, so this is what we see. All right, now in order for us to further understand corrosion, well, let's talk about this diagram. I believe, okay, most of you or some of you have seen it in your class, okay, on in your textbook, whereby this whole thing is classified as a corrosion cell, let's say, for example. So now when we talk about corrosion cell, well, first and foremost, we have to have at least, okay, 4 so-called conditions by which to complete the whole process. First and foremost, you need to have anode. All right, then you need to have what we call cathode. All right, so now anode and cathode is the one you have to have. If without them, then you will not be able to get into this condition already. Well, in the process of anode, why I need anode? Anode is a place whereby they will release it, so-called the ion as well as electron. And then you give me ion, you give me electron, then I have to have a place whereby someone must be willing to accept. Now, the place that will accept all the electron, well, is classified or is named as cathode. All right. So you need to have cathode at the same time. Then other than that, I'm sure you, by looking into this diagram, you know, oh, you need to have a path. All right. A path for them to travel, or for the so-called electron to travel. And the path can be either metallic path or electrolytic path. And also you need to have a medium, all right? A medium for the corrosion process to take place. So without one of them, corrosion will not be able to take place. All right. So this is the basic fundamental of corrosion or rusting process, okay, in a layman term. All right. Now the question again, do all metals corrode? All right, metal will corrode. I believe this is how we mentioned. Metal, they will corrode. Okay. So for example, where's my mouse again? So metal, okay, for example, metal X, metal Y, metal Z, for example. Okay, well, we understand, oh, some metal will corrode faster than the other, okay, for example. But the answer is that, will they stop corroding, or is there something that will not be able to corrode at all? Okay, the answer is no. All right. You will not be able to find something not able to corrode at all unless they are available in the original condition, which is a stable, all right, stable, unless they are available in the stable condition. So most of the thing will corrode. Nothing under the sun will not corrode, because whatever that we do, they are all available at the unstable condition. Still remember? Why? Because we convert them from a stable condition into unstable condition. So given the right combination, gold, okay, for example, gold, we know, oh, gold will remain shining and sparkling, isn't it? But gold also will somehow, okay, turn back into their unstable condition. All right, so they will corrode only a couple of what we call factor. Okay, can we provide the necessary conditions for them to convert into original condition? So that's why when you talk about metal, all right, metal will be able to return to their original condition, for example. It's all depending on how active they are. So in other words, how much energy they have in the structure. Are they stable? This one I told you they are unstable, isn't it? So unstable meaning to say, oh, they'll be having a lot of energy. Now the question is that to see whether how much energy they have. The more energy they have, all right, the more unstable they are, then the more energy they have. The more energy they have, then they will return to their original condition very easily. All right. For example, you can see, all right, zinc, you can see, no, so-called iron. All right. They get corroded very easily. Okay. And metal plates, no, I mean having lower energy, for example, gold, all right, platinum, all right, so-called no palladium, okay, they will not corrode. The question is not will not corrode. It's not meant they don't corrode, but then they will corrode slower. Why? Because they have lower energy. Okay. Now, how do I so-called place all that? All right. So the question is going to be very simple. The answer is lies in the fact that metal involves the corrosion, oxidation of metal. Now, in order for us to understand this, then I'm sure, like I said just now, we have metal X, metal Y, and metal Z, each of them having different energy. Okay. So to make our life easier, then we will convert them or group them into a table. All right. So by studying their behavior, you can see, oh, for example, silver, for example, gold, oh, for example, even stainless steel, they are least, all right, least susceptible to corrosion attack. So meaning to say they are more noble, more stable. And those, okay, located at the top of the table, unfortunately, oh, you can see magnesium, you can see zinc, you can see aluminum, all right, you can see the steel that we use at home, they are all located at the top of the table. So they will stand a very high chance to corrode. So that's why in the process of using, all right, to prevent corrosion, then what should we do? We should actually select metal from the bottom of the table so that, all right, they were not so easy to corrode. Okay, so this is one of the things we can do. Okay, but the question is that if I were to use gold, can I use gold to build a chair? Can I use gold to build a house? Okay, the question is no, because they are very expensive, isn't it? So due to this reason, we have to so-called find ways to make sure the steel that we use at home can last, all right, can last long. So how do we know? Or how can we do? So we have to understand them. All right, understand how they corrode, and then from the understanding of the corrosion process, we try to prevent them. All right, try to slow down the corrosion process. So that's why today I'm gonna share, all right, the types of corrosion process over here. And of course, okay, I can't, I'm so sorry, I can't, explain each of them in detail. Okay, what I'm gonna do today is actually let, all of you to have a brief understanding. For example, we will look into general corrosion. We will look into maybe pitting corrosion. We will look into those famous one, governing corrosion, stress corrosion, cracking, or a little bit of what we call crevice corrosion and so on. Okay, so these are the things that we have, or the time that we have, in order for us to to venture into some so-called these types of famous or important corrosion process. All right, first and foremost, let's talk about uniform corrosion. All right, uniform corrosion is a corrosion process that we see, all right, almost every day in our life. All right, so that's why, because of that reason, then I will introduce this to you. All right, the name is called uniform corrosion. Now, this is considered as the most common forms of corrosion, whereby the attack is on the surface of the metal. All right, we can't run away from this type of corrosion, then it's executed by the surrounding. All right, so now the extent of this corrosion is easily discernible. So meaning to say, it's easily, you can see it. All right, because it's occur on the surface. All right, on the surface of the metal. Oh, I might lost my mouse again. So it's gonna be on the surface. Okay, it's so easily to see. You can see it. All right, and then this sub corrosion process is relatively has low impact. Okay, I repeat, has low impact on the performance of the material. All right, so they don't cause so much of problem. All right, they don't cause so much of problem. So for example, you can see, all right, this is a hull of the ship, all right, whereby they do suffer corrosion. Okay, suffer corrosion. So this is a uniform corrosion. So meaning to say, uniform corrosion is a corrosion process that happen on the surface. All right, so-called uniformly distribution on the surface. So these are the corrosion process. Of course, given time, if let's say you do not do enough protection, well, they will break into two. All right, so the question is that they will become thinner and thinner. All right, so this is what we see. And then this is a gears. All right. So originally they don't found to be in this form, but when they start to corrode, well, you can see, well, they are not able to last. Okay. Then the surface become rough and so on. Okay. Once the surface become rough and flaky, then the gear will not be able to work in the way that you want. Okay. So there's something very sad. Now, this is also another typical example of so-called corrosion, uniform corrosion, where you can see, the surface start to corrode uniformly. You can see oxide film is formed, and then given time, the structure will become thinner and thinner, then they will feel like that at the end of the day. All right. So this is uniform corrosion. Now, the next one is talking about galvanic corrosion. Galvanic corrosion is something we see also every day, but the question is that no, we might not be able to understand or realize in fact they are belong to galvanic corrosion. Now, to understand galvanic corrosion, first and foremost, it's a corrosion process that involves at least two metal and above. All right, then it's then only we talk about galvanic corrosion. Then it is under the different electrochemical potential. Meaning to say, if I have metal A and metal B contact, all right, like I said just now, still remember the table we saw? All right, let's say metal A is more stable, metal B is less stable. When I would contact these two metals together, what happened? Metal A will corrode. So this is galvanic corrosion. All right, so it's all depends on the electrochemical potential between metal to metal contact. Of course, within the presence of electrolyte. Okay. Now the magnitude of galvanic corrosion depends on how much potential difference between the two metal. Okay. The bigger the electro potential between the two metal, the faster the process will take place. All right. So meaning to say, let's say I will use another metal X compared with metal A, for example. Then let's say this metal A is very reactive. Then metal A will corrode faster than the combination between metal A and B. So this is a definition of the sentence over here. So what is galvanic corrosion? Galvanic corrosion, like I said just now, to understand this, you have to understand there is a galvanic series. Okay, the same table. All right, from the table itself, then we have to use. Okay, for example, noble. Those very active one is actually anode. Those which is very noble one will be cathode. So meaning to say, if I use magnesium and maybe steel, well, who will corrode? Magnesium will corrode. But if let's say I use magnesium and maybe titanium, all right, magnesium will corrode even faster when they will combine with steel. So that is the definition of corrosion, galvanic corrosion. All right. Now, what is galvanic corrosion? So in short, it's going to be depends on the metal, metal to metal contact. So for example, you can see I'm putting a brass screw here. Well, where is the position of the brass? So what my brass is going to be, all right, somewhere, let's say this is brass. So now when brass will be contact with iron, for example, so who will corrode? You will see that, iron will corrode instead of brass. That's why metal, brass, and this is going to be steel and then contact with brass. Then the brass will corrode. Okay, so this is an example of galvanic corrosion. So metal to metal contact. Yep. Now, let's look in the diagram. You can see, this is something you saw, isn't it? I believe you have seen that. All right, metal to metal, metal to metal, metal to metal. This part, why corrode? Because this part is more reactive than the surrounding. And then this part is more reactive to the surrounding, so they will corrode and so on. So this part will corrode instead of this part. Why? This is more stable. So metal to metal contact. This is very good. So you can see the nut corrode, and then the both will not corrode. Why? Because they have different electrochemical reactions. So that is where we see. Now, on the other hand, we are talking about crevice corrosion. So crevice corrosion is a corrosion process that happens when you have a concentration cell. All right, when there's a concentration between two local metal. For example, concentration of oxygen, concentration of water, all right, and concentration of electrolyte, for example. This is mainly caused by the formation of differential aeration cell. This is going to be a cell that leads to the formation of corrosion inside the crevice. So inside the crease meaning to say gaps lah. All right, gaps. So this is gap. Matter A, matter B. Oh, you can see corrosion happen in between the gaps. Okay, so this is what you see. Now you can see this is metal, this is metal. Then we have gaps in between. Well, if you have a high concentration of oxygen, like I said just now, what happened? This area will corrode. All right, this area will corrode, this area will corrode, for example. So it's talking about concentration of oxygen, concentration of water. Okay, so that is where we see. All right, now this is a pipe. All right, I believe you know what is pipe. Okay, this is a pipe. So pipe, you can see, where the contact, all right, the pipe to pipe, the joint of the pipe, the oxygen went in, water went in. You can see this area become thinner. So this is something called crevice corrosion. This is also you can see the contact whereby the water oxygen went in, corrode. All right, eventually the thing became broken. This is also another thing you can see. All right, crevice corrosion. And then this is a washer. All right, this is the so-called bowl. You can see this area also corrode. Okay, why? Because the oxygen and water went in. And this is another typical example, okay, whereby you can see the gasket. All right, the gasket, between the gasket and the metal. So somehow or other, water penetrated in, or water seeped in. Then there you go, corrosion process is taking place. So that is something we have to do, okay, to prevent, okay, if we know what is going on, or else the process will remain there forever. Okay. All right, now the next one is talking about pitting corrosion. Now, pitting corrosion also we see it, okay, almost every day in our daily life. So it's considered as one of the most, okay, so-called dangerous types of corrosion. I repeat, the most dangerous type of corrosion, meaning to say, if whatever we can, we have to do our best to prevent this from happening. All right, for example, let's say I have a pipeline, okay, carrying water. All right, so if I suffer pitting corrosion, then ultimately the pipe will burst. All right, let's say carrying water is still okay. Let's say carrying gas, and maybe petrol, then will be very problematic, isn't it? So why is occur at the local point? The keyword here is local point. Okay, local point and proceed with the corrosion process, okay, surrounding the normal metallic surface. So once they form at this point, they only form at this point. They don't move around. All right, like uniform corrosion, they are not greedy. When the corrosion so-called process attack this place, then they will be attacking this place forever. They won't say, oh, I want to move to somewhere else. No. All right. So once they take place, then a pit will slowly penetrate into the metal. Well, you can see the pit slowly, they'll get deeper and deeper in time, even in stainless steel oil, too bad. Then you're going to find out that, well, ultimately the pipe will okay, or the plate will become, you will form a hole there. All right, a hole will be formed on the surface of the plate or even the pipeline. So the pit slowly penetrate, okay, metal from the surface in the vertical direction, vertical direction, and then ultimately they will lead to failure, structural failure, if let's say left unchecked. Okay, so this is pitting corrosion. All right, so they will only concentrate on one area. Now let's take a look into some example. This is pitting corrosion. Have you ever seen this in your daily life, in your surrounding? Have you ever seen, okay, a pipe, again, let's say we'll have pitting corrosion like that. Given time, you will know that, they will penetrate through the surface of the metal. And also, this is something, fail at the end of the pipe. All right, and then the pipe broken, then we actually we cut it up, so-called dissect it, and then look at it. You can see the surface or the inner part of the pipe, in fact, is beyond recognition anymore. All right, so this is pitting corrosion. Now the next one is talking about stress corrosion cracking. Now stress corrosion cracking is similar to what we've seen before, but the only thing is that this process, or this so-called corrosion process, involves some external factor. For example, tensile force. All right, the structure is having additional energy. All right, this is tensile energy is considered as energy. They have additional energy. All right, so now if let's say they have an additional energy, well, this process will take place even faster. All right, so the metal already itself having energy. The metal already super unhappy. they want to return to the original condition, then coupled with the fact that you are providing additional energy, well, they will fail faster. Okay, so that is stress corrosion cracking. Okay, simple. Now the cracking of the metal is a result of the so-called corrosive environment, as well as there's an S missing here, tensile, so-called stress placed on the metal. It's often occur at high temperature. Well, that is now you can see, they start to crack. All right, why? Because you apply a force over here. Okay, so they start to crack. So this is stress corrosion cracking in a very simple explanation form. Well, you can see, maybe this is a holder, the thing they will start to crack. You can see the joint, start to crack. All right, you can see, once it crack, they will even, so-called, break into two. And then you can see, this is a place, they crack, also they break into two. Why? Like I say, they have extra energy. So the extra energy will accelerate the corrosion process. Okay, and then if you were to dissect it, actually do a so-called observation, you can see the stress, that we have, and then will make the metal to the crack to propagate into the material. Okay, so this is something that will accelerate the corrosion process. Okay, well, the next one is called high temperature process or high temperature corrosion. Now, this high temperature corrosion is, of course, happen at high temperature. All right, so there's something that we have. For example, this is mostly related to industry, whereby the temperature is very high, and coupled with the fact that we have some oxygen, high temperature oxygen or sulfur. All right, and then some some oxidizing material. Oxidizing the material, the metal. All right, in this case, so it's all coupled with the fact high temperature as well as temperature, as well as some gases. So the metal start to corrode. Okay, so how the process will take place? Okay, very simple. Look at diagram figure ABCD. First and foremost, you have from the atmosphere, oxygen will come in. All right, when oxygen will come in, what happen? Oxygen will attack the metal, so they will form oxide. Okay, form oxide. Then given time, the oxide film will be grow, all right, in the horizontal so-called direction, and ultimately they will become one film. Okay, and this film, like I said just now, is an oxide film, and this film is a very active film. And then since the temperature is higher, and the formation of this active film will be even faster. So in no time to come, they will fail. Okay, why? Because the temperature is so high. Okay, so this is another process where we see. All right, so these are all the corrosion process that we have. And then and again you can see the example, they become oxidized, then they will the inner part, and then they will somehow so-called fail. All right, the oxidation process. Now the effects is what? The effects, I think you all know by now. They will weaken the structure, and then they'll become unstable. All right, and then the pipe will start to collapse and then and fail and so on. Okay, so that is where we see. So that's why the annual cost of corrosion worldwide is about 3% of the world GDP. All right, so that's why you can see the structure will fail, bridge will fail. All right, maybe machine will fail to work and so on. Okay, well, after knowing this, how can we do? What do we do if you want to prevent corrosion process? Okay, so there are 4 methods. Okay, in short, and you can use first and foremost non-corrosive metal. Second one is to use paint. The third one is to do some protection, sacrificial anode, and then the simple one is to make sure the surface is clean and dry. Okay, now let's explore. All right, each of them one by one. Okay. All right, now let's talk about first and foremost, how do we do if you want to prevent corrosion in the process or in the method of having to introduce a barrier coating. All right, so this barrier coating is very simple. Apply, for example, paint, plastic or powder, adhere to the metal surface to create a thin film. Okay, so it's something, this is a metal I want to protect. I just put different forms of what we call coating. Okay, of course, you can actually so-called, there are quite a number, okay, whereby I don't want to elaborate further here. And then, for example, they have a primer coat, as an inhibitor, intermediate coat, all right, and then a finishing coat and so on. So the intention is to prevent who? prevent oxygen, prevent water from getting to contact with who? Contact to the metal. Okay, so of course, before the coating, all right, after the coating, simple, isn't it? This is simple. Now the next one, the barrel coating, of course, you can see some example that you know that we used to see in our daily life. All right, spray, all right, the brushing process, or even dipping the whole thing, the whole car, I mean into a coating material and so on. So this is simple. All right. Now the second one is called applying the hot dip galvanizing. Now, hot dip galvanizing is another process that used very popularly in our country, whereby it is coated, all right, with a layer of zinc. Okay, meaning to say the corrosion prevention method involves dipping steel in the molten zinc. So very simple. We will then apply a layer of zinc there. All right. So then to let the zinc protect the metal. That's it. All right. So you have to make sure the zinc is always there. Now, once the zinc becomes depleted, all right, become thinner and thinner until the whole thing become depleted, well, this area will attack. Okay, corrosion process will attack. So you have to make sure the zinc surface is always there, or else, okay, the metal will be attacked. All right. I mean, eventually. So how the thing is done? Well, it's done by dipping them into a so-called quite a number of processes that is called galvanic process. So we are not going to discuss in detail each of them, but all I know is that I will dip them ultimately in the zinc bath, and after that, okay, we will get a zinc coating formed at the surface of the metal. So this is basically what we see over here. All right, now hot dip galvanizing. Well, this is the one I show you just now, or I told you just now. Dip it in the molten bath of zinc, and then use them. For structural application, for example. All right, can use to build structure, or even to build, or for coating of this. I think a handrail over here. So this is a layer of zinc coated, or galvanizing process. So whenever you see, all right, the surface of the metal having a texture like that, it's already been coated with a layer of zinc. Okay, so this is hot dip galvanizing. Okay, now the next one is gonna be something that we know. Let me see how much time I have. Okay, so it's called alloy steel. So now alloy steel is something that, I will turn the metal from having able to corrode fast and then to delay the corrosion process. So what should I do? Then I have to add something in the metal. So add something in the steel. For example, adding nickel. For example, adding chromium. Now, when we do add nickel and chromium into a stainless, into a steel, then this metal becomes stainless steel. So the chromium that we have to add in has to be at least minimum 11%, or even 11 to 12% minimum. If let's say the chromium content is not higher than that, well, you can't get the corrosion so-called protection that you want. So very simple, add in chromium. It's written here 11, okay, about 11%, 12%, okay, or 10.5%. All right, so now you can see once our friend is so-called added, now who is doing the job? The chromium will be doing the job, and the chromium will contact with oxygen, and they will form a protective oxide layer, and this oxide layer is a passive oxide layer, not active layer. So since actually it will be passive, so it will last for a long period of time. Okay, so this is stainless steel. Okay, now the next one is you have different stainless steel over here. Of course, you can see the chromium content, all right, 11 or 10.5 or even 12% minimally. Well, can be go as high as 30%. Okay, so that's why due to this reason, you have different classes of stainless steel can be used or to be used. Okay, for example. So there are mainly 5 main different classes of stainless steel. So each of them have their own function and property, for example. Okay. Now the next one is talking about catalytic protection. Now this catalytic protection process is a process whereby I control the process by means of electrochemical reaction. So to prevent this corrosion, the active side of the metal is converted into a passive side by providing electron to the surface. All right. So typically, galvanic anode attached to the surface metal near the metal used for anode, okay, for example, magnesium, aluminum, or even zinc. Okay, now, how do I know? We know for sure metal will corrode, isn't it? So now what I'm going to do here, actually, I am going to so-called attach another metal to the metal I want to protect. So let's say this is a metal I want to protect. So I will add additionally one piece of metal. And then this metal has to be more reactive than the metal we are protecting. Now, since the metal we are added is more active than the metal that we are protecting, automatically the metal will become cathode. All right, the metal will become cathode. So that's why in this case here, who is protecting who? The anode is protecting the metal that I want to protect. So this is called catalytic protection. Now I repeat, catalytic protection is a process of making the metal that I want to protect into cathode. All right, like I told you just now, corrosion process involves anode and cathode. All right, anode is a place that we corrode. Okay, so if I want to totally prevent corrosion for this metal to be protected, what I can do is that I convert the whole metal into cathode in total. So what I can do is to add another metal there. Simple, okay, very simple. So that's why you can see this process is called one of the process. If you were to use something to sacrifice, okay, something to protect, let's say I'm using magnesium, all right, to protect the pipeline which is buried underground, what I can do, I will select magnesium because magnesium is more reactive than iron, all right, than my pipeline. So the magnesium will sacrifice itself to protect the metal. Okay, so this is called sacrificial anode. Okay, sacrificial anode. So it's still under the categories of cathodic protection. Why? Because I make this whole pipeline into cathode. Since I'm making this whole pipeline into cathode, well, the pipeline will not be able to corrode unless there's no more anode, unless there's no more magnesium. So in this process, we have to periodically check and replace whether the magnesium is there or not. All right. So if let's say the magnesium is habis, what you will see, you'll find you have to replace it. Okay. So this is used for protecting maybe let's say underwater structure. Can you see there's a magnesium is attached? All right. So to protect, and then for a pipeline, so I have to use anode. Who is this anode? Is also magnesium, and also the ship. Okay, this is a propeller. This is also magnesium or zinc, and where originally they are in good condition, it's like that. Then after a certain period of time, they become thinner and thinner. Then you have to change it. Okay, from time to time. Okay, so this is sacrificial anode. Now the another method is that instead of using what we call anode that can consume or which is consumable, well, we will try to use another method whereby we use power supply. Now this power supply is very simple. You just use a DC power supply, and the positive terminal has to be connected to a metal. This metal can be any metal, but of course, it's recommended you use maybe platinum or even graphite and so on, okay, because they are inert, okay. But the protection coming from where? The protection is coming from the power supply, okay. The protection is not coming from the anode. The protection is coming from power supply. So what the intention is very simple. Like I said just now, convert the metal to be cathode, okay, to become cathode. So this is how you do it, and you will get the protection that you want. Okay. Now, impressed current protection is gonna be very simple. This method is called impressed current protection. Well, what you can do here is actually by supplying battery, okay, to the anode will corrode instead of the pipeline you want to protect. Okay. Now, like I say, pipeline. All right. So power supply. So then the energy, the electron will be provided to protect the pipeline. Okay. This is the better picture here. So that's where you can see the protection is done through the power supply. Okay. The protection is done by the power supply, not by the zinc. So this is a little bit different. Okay, but the concept is the same. Okay. So for example, a tank, also the same. Okay. So this is impressed current catalytic protection. All right. So now these are all the time I have with you guys. Oh, I have another 5 minutes left. So is there any question for me? Then if not, maybe I will try to. Any question? Or do we have time to do a quiz? Hello, can you hear me? Hello. 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 Can you hear? Hello. Hello.
Hello, yes, will
Yeah,
we
yeah.
proceed with the Q&A session or quiz?
Do we have time or not for the Q&A?
Yeah, we do have time for Q&A.
Okay. Now let me see. Let me so call my screen first. Okay, so now let's have maybe a simple Q&A here. All right, just to complete. Okay, you can see my screen, yeah. All right, so now maybe we try to so-called log into this. Yeah, I can't see my screen there. Can you see? Can you see what I'm typing right now?
Yes.
Okay, so now let's maybe join this so-called, there's a quiz here. So where I know, yeah, that's one. Okay, so now all you need to do is that, wait, okay, need to do is that this Kahoot. Again, I'm not sure whether you know or not, but somehow it's a very simple one, so can support up to 50 participants. Now, what you need to do over here is that later on, once the pin is created, then you just screenshot, all right, not screenshot, scan the QR code here and key in, all right, the game pin using your mobile phone, and then you should be able to see your name appears here. So can you try? Can you see my screen or not? Hello?
Yes, we can see the screen.
Okay, so just scan and then key in the what we call the thing there. Okay, I can see Ida, I can see 559. This is okay, the what? And also who else? Who else? Come in. Okay, those who can answer the fastest one will be having some souvenir from the organizer. Okay, I have 3 participants so far. Oh, I have 4 Excel. Any more? Any more participants? Only 4. Hello. Only 3. Okay, now mind, we just try, try any more. Hello. No, that's all. Okay, so let's try. So I will start. Okay, I have Christmas here. Wow, it's Sissy here. Okay, so maybe I wait for another few seconds. Okay, maybe 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, Alvin, welcome. Okay, let's start. So I will start the quiz, about 15 questions altogether. Okay, see whether how many questions you can answer. You have to choose the right answer and also the fastest one. So there's a true and false question. So you just see matter Russ. Okay, so it's a reaction. Is it correct or not? Just press what you see in the yes. One answer, one student answer already. So press true or false on your handphone. Yeah, for answer. Okay, wow, we have 6 students or 6 participants got it right. See, let's see who is the fastest. Wow, Christmas seems to be the fastest. Okay, your score is 938. Well, let's go to another question. So another question, what is the chemical nature of rust? Wow, it's a bit difficult. So see who can press the fastest. Okay, well, let me see who answer already. No, still have 0 answer. 1 answer, 3 answer, 4 answer, 5 answer. And then, wow, we have 5 students got it right and 1 student got it wrong, I guess. So let's see. Okay, 0 student, ayo, never mind, let's find out. Now, none of your Christmas still remain the highest. Okay, never mind. Okay. The next one, the next question, which of the following statement is wrong? Okay. So you have to read carefully. The question can be a little bit tricky. Okay, so any answer? Any answer? Only one answer. Wow, that time's up. Okay, who got it right? Okay, let's see. Oh, wow, Ivy, no got it right. And you are the champion right now. Now, question number 4. Which of the following are essential for rust to occur? High temperature, water, or oxygen? Which one? Wow, this comes so fast. One more. And yeah, so then let's say who all got it right, no? Wow, say who is the fastest? Again, Ivy is the highest. Wow, Christmas number 2, okay? Have to work harder to catch up. Question number 5. Iron is known to have good tensile strength and rigidity. When it's subjected to rust, iron will become what? I mentioned before. Iron become what? Oh. Okay, one more. Okay. Wow, I got 4 students. No, got it right. So 2 students got it wrong. So who is the champion again? Wow, Ivy still remain the top. Wow, we have to catch up. Alvin, work harder. Question number 6. Which of the 2 things cause iron? This question is simple, very simple question. No, we did mention before. See who got it right? Water ka, oxygen ka, carbon dioxide ka? Okay, we got 3 right answer, 3 wrong answer. So let's find out together who get it right. Wow, CC, got 3 answer, straight away. Then Alvin, wow, become the champion already. Congratulations, make sure you work, maintain this performance. This is a bit difficult already. This type of corrosion has relatively low impact. Which one having low impact? Which corrosion process? Oh, okay, and now a few seconds left. Okay, wow, all got it right except 1 student. Okay, uniform corrosion, isn't it? It's less impact. Wow, who is the highest? Wow, Alvin got 4 answer. Okay, answer 4 questions straight away. I mean, in a row, this one also a bit difficult. Okay, but see whether can you answer it or not. This is a true or false question. Less harmful. You think corrosion is less harmful or true or false? Oh, I got 3 students right. 3 students wrong. Okay, let's see the scoreboard again. Wow, Alvin got it right. Oh, 5 answer, 5 strict. Answer again. Now, question number 9. Which statement is true for galvanic corrosion? Okay, this one read it. Read carefully. Can be tricky a little bit also. Okay, one more. Oh, okay. The answer is no large. Okay, the potential has to be large. Now, wow, Alvin. Okay, 6 answer in a row. Now, question number 10. Galvanizing is a process of what? Okay, adding who? Galvanizing is a process of adding who. Do you remember? Adding who into a metal. The galvanizing process is adding something into the metal. Adding who? Adding what? Oh, faster. Okay, adding what? Adding zinc. Okay, we got 3 students got it right. And then, Alvin is still the highest. Now question 11, another 4 question. Which of following statement is not correct? Okay, it's incorrect for corrosion protection. Incorrect. Read carefully. Not correct. Don't look for the right answer. Look for wrong answer. Okay. One answer. 2, 3, 4, 5. Okay. So use what? Use sacrificial analog. Okay. No, it's not correct. Now the next one. Oh, Alvin still remain at the top. The next one, which of following is seldom added? Which of the following alloy is seldom added? Stainless steel, we don't see what? We don't see chromium, nickel, zinc, or iron. Which one? I mentioned just now. Still remember from the paper? Okay. Who is the most popular? Okay, one more. Okay, so zinc is not added, isn't it? Zinc is not added. No, seldom added, not added at all. Okay, zinc, not chromium. Okay, Ivy now catch up already. Now question 13. Question 13, insufficient amount of chromium added will make the corrosion, the metal become corrosion resistant because what? Why adding chromium will make the metal become corrosion resistant? You remember? They will form a layer of protection. You remember that? So what is the meaning? Where to find the answer? Oh, okay. So it's the form of thin layer to protect, isn't it? Well, let's look for the next question. Ivy still remain at the top of the podium. Now find another 2 questions. Silver plating. We can use silver to prevent iron from corrosion. Why silver can prevent? So just now we mentioned already. All right, silver. Why silver can prevent? Okay, 2, 3, another 6 seconds, 5 seconds, 4 seconds. Oh, silver. Okay. Oh, none of you got it right. So yes. Okay. So again, I feel still remain the top. Okay, so Alvin, okay, have to work harder. You still have a chance. So final question. Let's see whether Alvin can catch up or not. Which method is used for underground piping? Still remember underground pipe. Okay, underground water pipe. Which method is used to protect underground piping? Is it impressed current protection, galvanizing, or sacrificial anode? Which method? Oh. Okay, method 1 and 3. Okay, yeah, there's the answer. So let's see who is the champion. The podium. Wow, number 3. Congratulations, Alvin. Number 2 is Christmas. Congratulations. Then number 1 is who? Well, dang, 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 dang. Who is Ivy? Okay, so I think this will be the champion. Will be the winner. All right, so that's it. Okay, for the test. Thank you so much for your participation. Okay, so just want to check. Can you all, for the winner, okay, can you all key in? Can you key in your email address into the chat box so that the organizer can contact you? All right, Ivan. Okay, with that, then I pass the time back to the MC for this event.
Thank you, TS. We will proceed with the Q&A session. Just a gentle reminder, please type your questions in the chat box.
Any question for me? Any question?
If you have no questions at the moment, but maybe you have questions after the session, you can place the questions in the Facebook Live comment.
Okay.
Okay, looks like we do not have any questions at the moment. Okay, dear participants, kindly fill out the sign out form and the feedback form after the webinar. Okay, now we would like to take a group photos with everyone in this webinar. Please turn on your camera and stand by. Yes, could you please stop sharing the screen?
Okay, let me see. Stop sharing. Stop share. I just press. Okay, is it okay?
Okay, ready everyone? 3, 2, 1, smile. Okay, let's take another one. So let's take a freestyle.
Freestyle.
Yeah.
Yeah.
So ready? 3, 2, 1, smile.
Okay, 3 fingers.
Okay, T.S. Ng, is there anything that you would like to cover before we wrap up?
No, that's it. That's it.
Okay, thank you, T.S. Ng, for the insightful webinar. Okay, dear participants, please join us for the next webinar titled Sport Science in Your Life at 11 a.m. today. Thank you, everyone, and stay safe.
Thank you. See you. Bye-bye.